I love physics statics, and although I already have an A in the class, I'm doing the unthinkable. I'm actually rereading the entire textbook with the help of one of my tutors from Argentina. I'm actually bilingual, so thankfully, because of that, I'm able to afford a tutor, otherwise I wouldn't be able to. And I run into a sub-chapter, which we really didn't dive into depth during the semester, that's quite valuable. So here I'm taking education into my own hands. And let me show you why wedges. I'm a huge fan of wedges. In the book, the way things work, wedges, or inclined planes, are actually a force amplifier that are used in many mechanisms. You see where I'm going with these mechanisms, such as keys. We also use them in, for example, hair clippers for beards or can openers. These are all wedges force amplifiers. On zippers. So we're redoing all these problems in the book. I'm taking very thorough notes. You may see here some of them in English, some in Spanish. I'm getting really good at this. And because I really want to understand how do wedges work, the inputs and the outputs. But the problems in the book, they only take you so far. For instance, in this problem, we wanted to see how much, what the horizontal force P would have to be in order to begin to push the wedge forward here. Now, this is a rather simple problem, and in conclusion, what you'll see is that if I apply a force that's equal or greater than 215 newtons, therefore the wedge, I'm translating everything as I go, will start to slide in both surfaces, okay? Pretty good at translating, right? Interpreting. So that's actually not enough for what I wanted, I told my tutor, because what if the wedge is not moving at the desired velocity? What if it moves just 1 micro inch per hour? Like, that's not fast enough, especially when you're designing mechanisms. So I told my tutor, hey, check this out. Let me take it over YouTube and show you one of the mechanisms I tore apart, which is a luggage handle mechanism. And as you'll see, there's this mechanism inside which allows to retract the pins once you press the button on the mechanism. So I brought it over and I said, hey, so how can we have an input of a desired, no, actually that's the output, the desired velocity and displacement, and how do we tie everything back to the problem in the book? And the answer is the following. We look at the kinematic equations, which many of you are already familiar with. Generally, the initial velocity is going to be 0. So we're looking at this rectangular gray box. So we're going to cancel that out. The final velocity, we need to assign some values. These are some arbitrary values. For the displacement, we put 5 millimeters, and then this is the final velocity. Now, once you find your acceleration doing this formula, now you can plug it in to F equals ma. You're already going to know the mass, you're going to know the acceleration, and this is going to give you the force. Now, this is what I wanted to for designing the mechanism. This is a force that will allow the object to move at a desired velocity for the desired displacement. I know that's an oversimplification, but in conclusion, I wanted to give you an inside scoop of what I do every day for a couple hours. I really want to be at the top of my niche when it comes to mechanism. And what drives me to become the best version of myself is my curiosity, but also my fear of failure, not knowing and being called a fake. I would never want someone to ask me how this mechanism works or design a mechanism, and for me to not know the physics behind it. So if you found this content of value, if you can relate to me, if you want to become the best version of yourself, go ahead and give me a follow on LinkedIn. I talk about mechanisms, CAD, SolidWorks, and mechanical engineering. This may be the last time you see one of my videos, so I highly urge you to click that like and follow. Rafael Testai, until next time.